Hey guys, this is example 3 for section 7.3. All right, so before I start, I'm going to tell you a joke, okay, that one of my daughters told me a few days ago. Why did the girl throw the butter out of the window? Why did the girl throw the butter out of the window? Because she wanted to see a butterfly. Get it? Because she wanted to see a butterfly, but it's butter and fly put together. There is your toddler joke for today. Ha ha ha. Example 3. Solve each. Give a general formula for all solutions. So I want to highlight this word right here. All solutions. List 6 solutions. Okay, so first you're going to give me a formula for all of them, and then you're going to list 6 of them. So solve, you're going to do it old school. Okay, so first I'm going to add radical 3 to both sides. The formatting of this looks a little bit weird. Hopefully it's better on your paper, on your notes packet, but I highly doubt it. Sorry about that. Okay, so 2 cosine of theta equals rad 3. Divide both sides by 2. So I'm going to move it here, because since the formatting, it's a little bit off. Cosine of theta is now positive rad 3 all over 2. Because this is a regular trig function, it has no restriction. That's why I can get all of the formula. And there are unlimited number of solutions. So let me just bring you back to this right here. See these right here, A, B, C, D, E, F? Notice how if I don't limit this here on a very first example, then there is no way that you can list them out, okay? So check that out. This has a restriction from 0 to 2 pi. Notice our last example here has no restrictions, okay? There's no restriction anywhere. See this? Okay, that's why you have to give me the formula. Okay, so cosine, it's going to be positive in here and here. So now you're going to give me the angle. Okay, there are 2 of them. Can you take a minute and tell me what this one is? What angle is that? Did you say pi over 6? Awesome. Okay, how about this one over here? Did you say 11 pi over 6? Great. Now, because there is no restriction, you can also say negative pi over 6. There's nothing wrong with give me one or the other. Again, because this is a regular trig function. So, how do you or how do us get an equation for all of them? So what we do is we're going to say, hey, how do I get back to this location every time? To get back to it, then you're adding a full revolution. And a full revolution is really 2 pi. But what if I want to add 2 full revolutions? Then you can use k. So say that where k is any integer. Okay. Same thing with this, right? How do I get back to, for the purpose of demonstrating, let me erase this. You don't have to, just keep it where you have it at. Okay, so we decided to have it here, which we'd already had. Okay, then here. Now how do I get back to here every time? Well, same thing, right? I would add a full revolution. So whatever answer you write down here, you write 2 pi k. And if k is 0, then you have your first answer originally. Then if k is 1, then now you are adding 12 pi over 6. 12 pi over 6 reduces down to 2 pi. So that's why you're going to end up with the next answer in the next period, okay? So, and again, where k is an integer. So how do we write this? Theta is pi over 6 plus 2 pi k, and yes, you will need 2 different equations. And theta equals, I'm going to use just positive angles here, plus 2 pi k. Okay, and then I can just spell the k one time because they're both the same set of integers, okay? K is any integer. So this is my equations. And then it said, hey, give me 6 of them. So for me, when it says give me 6 of them, I'm going to say, hey, let's k be 0. When k is 0, then I have pi over 6 and 11 pi over 6, okay? How about when k is 1? When k is 1, then remember, 1 is really 2 pi times 1, which is 2 pi. But I need to add it to the denominator of 6. So the first thing I'm going to do is I'm going to convert that into 12 pi over 6. So now I'm just going to go, hey, what if I add 12 pi over 6 to this? So now I have 13 pi over 6. What if I add 12 pi over 6 to that? So now I have 23 pi over 6. So that's a total of 4. Then I'm going to keep on going when k is 2. So when k is 2, what I do is I'm just going to add 12 pi over 6 to these. So 12 plus 13 is 25 pi over 6. And then 12 plus 23 is now 35 pi over 6. So your 6 solutions are, theta is pi over 6, 11 pi over 6, 13 pi over 6, 23 pi over 6, 25 pi over 6, and 35 pi over 6, okay? Now, do I have to have all positive solutions? No, but most of us prefer positive numbers over negative. There's nothing wrong with negative numbers. I will also accept them, but your book, I think, most likely will have all positive answers, so we're just going to keep it consistent with the solutions in the book. Okay, are you ready for B? B, we are going to do the same thing. Are you ready? I don't have to do anything, so now I'm just going to compose both sides by sine inverse. So theta equals sine inverse of 1. Okay, now, but the original question is not an inverse, so I don't have restriction really, but there's only one location that sine is going to be positive, which is pi over 2. Okay, so it looks like I only need to have one equation. So 2 theta equals pi over 2, okay? And again, I'm just going to go and add 2 pi k because that's what the period is for the regular parent function of sine. But if you see right here, there's this 2 in the front, so I'm going to multiply each and every term by 2. Okay, so now I'm going to solve. Theta is pi over 4 plus pi k, and where k is, the symbol means contains in any integer. Okay, so z is the symbol for integer, so fancy way of writing it. That's the equation. Now I'm going to go and add a pi k to each. So pi is, if you think about it, your period for this equation is 2 pi divided by b, right? And b is 2, so that's why you have a period of pi, and that's how this is right here is related. So what you are doing is that in each period, there's only one solution, versus in this question, each period has 2 equations. That's why there are 2, each period has 2 answers. That's why there are 2 equations. Okay, so how do I get the 6 answers? I'm going to do the same thing. I'm going to let k be 0. So if k is 0, your first angle is pi over 4. If k is 1, 1 times pi is pi, but pi with the denominator 4 is 4 pi, okay, over 4. So I'm going to add 4 pi over 4 every time. So the next one would be 5 pi over 4. When k is 2, then I'm going to add 4 pi over 4. 9 pi over 4, okay, is 3. Keep on going, okay, so until you get 6. So I'm going to have, let's see, 4 plus 9 is 13 pi over 4, okay, is 3, no, 4. I'm going to add 4 to 13, so this is going to be 17 pi over 4. How many answers is that? 1, 2, 3, 4, 5, and then one more. When k is 5, I'm going to add 4 pi to that, so that's going to be 21 pi over 4. So here are your 6 solutions. Theta is pi over 4, 5 pi over 4, 9 pi over 4, 13 pi over 4, 17 pi over 4, 21 pi over 4. And box that up. All right. Okay, so let's see. We did 2 problems already. One was involving cosine, one was involving sine, and then now we're on the last one, which is tangent. Okay, and if any time that you feel like this video is going too fast, rewind. Okay, pause. That's the beautiful thing about videos. Okay, last one. Let's do it. Tangent of theta divided by 2 equals 1. So similarly, I'm going to do composing tangent inverse. Okay. So tangent, remember the original is normal trig, no restriction. Tangent is positive in 1 and 3, right? So the question is, hey, theta divided by 2 is what? What quadrant, what angle in quad 1 is going to give me tangent of what in quad 1 is 1? Did you say pi over 4? Yay! Okay. How about quad 3? Tangent of what in quad 3 is also 1? Did you say 5 pi over 4? Okay, I'll take it. Now, normally, I'm going to say that you would write 2 equations, okay? But here's the thing. You can, writing 2 equations like the first one is perfectly correct because I can't make it equal to 1 equation, okay? And what I mean by this is, from one angle in quad 1, there is not an equal, let me get a different color, there is not an equal measurement, okay, on the left-hand side of it, and there's not an equal measurement on the right-hand side of it for me to get to one another without using both locations. But for this one, this angle, instead of adding 2 pi to get back to itself, what I can do is first erase, okay? What I can do is I'm gonna add pi, oops, I just erased. I'm gonna, let me mark this back. I'm gonna add half a circle to get to the second answer. Half a circle is pi. So it's easier, as you can see, to just add a pi. Why do I add a pi? Because pi is also the period for y equals tangent of x. So you can see I'm adding just pretty much the period for each of these equations, okay? So pi over 4 plus pi, because that's the period. And then we add k at the end because we will have to define what k is. But I still have to solve for theta by multiplying each and everything by 2. Okay? So now theta is 2 pi divided by 4, reduce that to pi over 2, plus 2 pi k, where k is contained, this means contained or in, or belongs, and the integer. So that right there is one equation, okay? And you can only have one equation for tangent because the angles right directly across from one another are resulting in the same exact solution, okay? Only for tangent and cotangent. If you write 2 equations, I'm gonna take points off because it's kind of like not reducing, so keep that in mind. Now let's write down our first 6 solutions. I'm gonna let k be 0. If k is 0, then I'm gonna have an angle at pi over 2. K is 1. then if you see this, I'm really adding a pi. I'm sorry, not a pi, 2 pi. And, oops, and 2 pi is like 4 pi over 2, right? Common, oops, I don't know, 2. Common denominator, okay? So if I add 4 pi over 2 to pi over 2, then now I have pi over 2. K is 2, add another 4 pi over 2, that's 9 pi over 2. K equals 3. That means theta is 4 plus 9 is 13 pi over 2. K equals 4. I add another 4 pi, that's 17 pi over 2. K equals 5. Last one. And that's going to be 4 plus 17 is 21 pi over 2. So your first 6 angles are, let's write it down so we can box it up. Here we go. Ready? Pi over 2, 5 pi over 2, 9 pi over 2, 13 pi over 2, 17 pi over 2, 21 pi over 2, and voila. So those are the 6 solutions, and these over here are your equation. And yes, you do need to know how to write your equation. Okay, this is the end of our 7.3 notes.